Hi learners, this is Tutor Marife. In the previous videos, we've found x equals 1 as the valid solution of this given equation. This time, let's solve for the other real number x that also satisfies this given equation. Let's use the second factor of this equation in terms of variables a and b to find the other solution of this equation, 2a minus 3b. By application of the zero product property, equate this factor to 0, then let's find the other real number x that satisfies this equation. Remember that in the first video, we've done these representations. We've let 2 raised to the power of x equals a. We've also let 3 raised to the power of x equals b. So substitute 2 raised to the power of x back into a. Substitute 3 raised to the power of x back into b. By substitution, this equation becomes 2 times 2 raised to the power of x minus 3 times 3 raised to the power of x equals 0. Then transpose this negative term on the left to the right side of the equation. By transposition, we have this resulting equation. 2 times 2 raised to the power of x equals 3 times 3 raised to the power of x. Remember that any number has an invisible exponent of 1. So this expression on the left is just the same as 2 raised to the power of 1 times 2 raised to the power of x. And this expression on the right is just the same as 3 raised to the power of 1 times 3 raised to the power of x. Now observe that we're multiplying exponential expressions with the same base, so we can apply the product law of exponents. Based on the product law of exponents, when we multiply exponential expressions with the same base, keep the common base, then add up the exponents. By application of this law into this equation, we keep the common base 2, then add up exponents 1 and x. We keep the common base 3, then add up exponents 1 and x. We now have this resulting equation wherein we have 2 exponential expressions with different base numbers but with the same exponent. For this exponential equation to hold true, the common exponent must be 0, so that by zero exponent law, which states that any non-zero base number raised to the power of 0 is always equal to 1, each side of this exponential equation becomes 1, and 1 equal to 1 is a true statement. Therefore, to hold this exponential equation true and to solve for the unknown x, let's equate this common exponent 1 plus x to 0. Then isolate x on the left side by application of the subtraction property of equality. To isolate x, eliminate 1. To eliminate 1, subtract 1 from both sides of the equation. 1 minus 1 is 0, x remains on the left side, and it's equal to 0 minus 1, or negative 1. X equals negative 1 is the other real number x that also satisfies this given equation.